Assalamu alaikum students, myself Zain Javed Mughal, your science teacher. So students, in the previous lecture we have dealt with the definition of heat, thermal energy and some of the sources of heat. In that lecture, we had concluded that the heat is the transit form of thermal energy. And we have already studied the one rule of transfer of heat, that the heat or thermal energy is always transferred from the warmer body to the colder body. And while concluding the sources of heat, so we have two types of sources. One are called as natural sources, and the other is called as artificial sources. So, in the natural sources, we have dealt with the sun, stars, fossil fuels, wood, electricity, and not electricity, and food. And in the artificial category, we have studied the electricity as a source of heat or thermal energy. Afterwards, we have also discussed the effects of sources of heat energy, in which we have dealt with the change in size, change in state, and rise in temperature. So, these are the main points of the previous lecture. Now, we are going to start a new topic in this lecture, that is thermal expansion and contraction of solids. So, what does thermal means? Thermal means, as I have foretold you in the previous lecture, that therm means heat and expansion means to expand. To increase the size or volume of anything is called as expansion. So therm means heat and expansion means to expand. It means that the thermal expansion is defined as the expansion or the increase in length or volume of any matter due to heating or due to thermal energy is called as thermal expansion. Okay, students? Therm means heat and expansion means to increase in volume or size of a matter. So, the expansion or the increase in length or a volume of matter due to heating is called as thermal expansion. And this topic we will deal with the thermal expansion and as well as the contraction of solids. So, class, first of all, we are going to deal with the solid state of matter. We are going to see that how the solid expands or contracts upon the thermal energy. So, first of all, solid is what? Solid is a state of matter. So, in the solid objects, atoms or molecules are tightly fixed. You know that in the classroom, I have told you that if we are going to see the molecular arrangement of the different states of matter, so the solid has a very tightly packed structure, therefore it has a definite shape. The liquid has a slightly far apart molecules, and the gas has a very, very far apart molecules. So, right now we are dealing with the solid state of matter. And so, in solid state of matter, the forces of attraction between the atoms are too much high. Why? Because they are too much near to each other. They are compactly packed. They are tightly packed. Therefore, when the molecules are tightly packed with each other, they are nearer to each other, so they are applying the highest force of attraction to each other. So in the solid state of matter, as the particles are next to each other, they are tightly packed, there is a very low space between the molecule, so the forces of attraction between the molecules are so strong that they can only vibrate about their fixed positions. They cannot move freely like a liquid, like a gas, but the particles of solid can only be fixed and vibrate in a chemical structure. So the molecules is only able to vibrate about their fixed positions. It means that the shape of the solid is definite. Okay, if I can draw a molecule over here, so you can see that the shape of the molecule is definite. And there is a very less space between the molecules of solid. And these solid molecules vibrate at their fixed position like that, like that, like that. They are going to move to and fro motion like that at their fixed position. So this is all about the molecular state of solid. Now, how the solid expands? What is the mechanism followed inside it? How the molecular arrangement differs when the expansion occurs? So, when the heat is applied to a solid form, some source, atoms gain thermal energy. You remember that I have told you that whenever you are providing a heat to any of the molecule, that heat will be absorbed by the atoms or the molecules. Remember that whenever you are giving a heat from any source to a solid, liquid, or gas particles, these particles gain that thermal energy. And then this thermal energy basically increases the kinetic energy. I have told you that, students, every body that is in the state of motion, in the state of movement, they possess kinetic energy. And the every body that are is in the state of rest, in the stationary condition, so it can contain potential energy. But now in this case, you know that when the heat is provided to the atoms, so the heat should be absorbed by the atoms, and this heat increases the kinetic energy. Because whenever you are supplying the heat or whenever you are giving the heat to a particular solid, the molecules of solids vibrate, and vibration is also a motion. So every motion containing body, every moving body possesses an energy that is called as kinetic energy. So whenever you're providing the heat to a solid, liquid, or gas particles, these particles increase their vibration and then increasing their kinetic energy. You can see over here that before heating, the solid is of that length, but when the heating is done, and we have observed that now the heating makes the solid to be expand. This is the whole area. This is the area by which the solid expand. You can clearly see over here. First of all, the length is that, and after the expansion, the length is that. So this is the basically the measurement of the expansion, that how much expansion occurs after the heating. So in this way, for example, consider this is an iron rod. So okay, this is an iron rod. So whenever the iron rod is get heated, its size increases. Why? Because it expands on the provision of heat. So solids expands when the heat is given to them. Okay, students. Now, okay, coming back to the topic. So the kinetic energy of the vibration increases. So then that vibration occurs vigorously. Vigorously means, students, a very fast with a high force. Means that whenever you are rubbing the two bricks to each other, so or two surfaces to each other, if you rub them very fast or very harshly, then the term that is used for this is vigorously. So after the provision of heat to the solid particles vibrate vigorously. These vibrations, these highly energetic vibration, result in basically the increase of distance between the particles. When the solid is not heated yet, so the molecules are near to each other, they are compactly packed. But when the heat is given to the molecule, the vibration occurs vigorously. These vibration increases the distance between the particles. Once they are compactly packed, now they are getting slightly far apart upon continuous heating. So these vibrations result in increase in distance between the particles and until the solid expands. So in this way, the ultimately after the increment in the distance between the particles, the solid expands upon heating, and this type of phenomena is called as thermal expansion of solids. Now, how the contraction of solid occurs? The contraction of a solid is the opposite of the thermal expansion. One thing is expanding, so the opposite of expansion is contraction. One is increasing the volume, and in the one contraction, the volume is going to be decreased, the size is going to be decreased. But in contrast, if you're talking about the expansion of something, expansion means to increase in volume, to increase in size. Okay, so in that case, thermal energy is extracted. While when we are giving the thermal energy to the solid, it expands. The thermal expansion is seen. But when the thermal energy is extracted out, when the thermal energy is given out from a solid through the flow of heat, is called as contraction. It's so easy, students. Listen. One thing is expanding. What is the basic phenomena behind this? Because we are giving the heat to the molecules of that state of matter, therefore these molecules vibrate and increases the distance between them and ultimately cause an expansion. But if we are going to deal or study the contraction of the solid, so it is a common sense that if we are giving a heat for expansion, so we are taking or extracted the heat back from the solid to let it get contract again. So in this way, when the thermal energy is extracted from a solid through a flow of heat, then this phenomena can ultimately lead to a contraction of a solid. This contraction decreases the kinetic energy of the particle and the vibration become less vigorous. Okay, so in the thermal expansion, the vibration becomes vigorous, and this vigorous vibration increases the kinetic energy, and that kinetic energy increases the spaces between or distance between the particles. But in contraction, it is wholly opposite, because in the expansion, the thermal energy is provided and the kinetic energy increases. But in contraction, the thermal energy is extracted and the kinetic energy of the particles decreases. So if the kinetic energy of the particles become decrease, so the vibration will be not more vigorous. They are leading or heading towards the less vigorous vibration. So these less vigorous vibrations can ultimately reduces the distance between the atoms, and ultimately it will lead to the decrement in the size of the solid, so ultimately the solid becomes contracted. So this phenomena in which the evolving or extraction of a heat is occur and the solid gets contract, so this type of phenomena in science is called as contraction of solid. Now, a question arises over here that what are the effects of these expansions and contractions of solid? Why they are important? What are their applications in our daily life? So, students, the thermal expansion and contraction of solids inconveniences us in different ways. There are a number of applications for the thermal expansion and contraction of solids, and I'm pretty sure that you are familiar with them. You have seen all these examples in your daily life, but you have not familiar with these concepts. So inshallah, I hope that after going through these concepts, now if you again observe that things, so you will remember, you will remind that this phenomena is basically due to the thermal expansion or due to the thermal due to the contraction of solid. So first of all, the thermal expansion affects our construction, the pipelines. You have seen that whenever the water or the gas pipelines are made, they are never made in a straight passageway, in a straight path. But from any point, they should be a bend. They contains a bend in between their way. So the bending of pipe is necessary. Why it is necessary? Because you know that the pipe is made up of solid particles. It is made up of solid. So whenever in the summer season, in the summer days, hot summer days, when the heat is enough for the particles to increase their kinetic energy. So when the kinetic energy is increased by the absorption of sunlight, the natural source of heat, so the vibration of the molecules become vigorous. And this vibration of molecules basically ultimately lead to the crack on the expansion of the pipelines. So to avoid this crack due to the expansion, we have placed a bend in their path. So when the bend is present in the path, so there must be a enough space to expand from the bending side and does not crack. So this is the first application that the pipelines, either it was of water pipelines or gas pipelines, they are made bend to avoid the destruction, to avoid the cracking upon the expansion in the hot summer days. And while the in the cold days, when the molecules get less vigorous vibrations and the kinetic energy of the molecule decreases, so these expanded pipelines again contracts and becomes to their original position. So this is how the bending of pipeline is mainly done, or they are manufactured on the basis of these phenomena that we have foretold studied, that the thermal expansion and contraction of solid. Now the second is damage in railway tracks. If you have visited a railway station and you have seen the railway track, when the railway tracks are lying on the floor, the railway tracks are not completely joined together. They have an enough space between the two junctions. Why there is a gap left between the segments of metal railway? Because you know that the metals are the good conductor of heat. So, in the hot summer days, when the heat is enough for the metal to gain the kinetic energy and increase in the and it will increase the vibration of the molecules, and the vibration as we will be vigorous. So, this vigorous vibration will ultimately lead to the increment in the distance between the particles. And if the distance between the particles increases, so the gaps, if not present there, so the bending or the deformation of the railway track should be occur. As you can clearly see the image behind you at this paragraph, the railway track is not as straight as they should be, but it is like a wavy pattern. And this wavy pattern can be a cause of the major accidents of the railway. So the gaps are left between the segments of metal railway tracks to allow for expansion. So therefore, the reason behind the placing the gaps between the segments is that whenever the hot summer season is there, these gaps allow the expansion of the metal rails, and these metals get expanded and then joined together. And whenever the contraction should be